Hello everybody and welcome to another Macaroni Machine math movie production where you get to play the therapist and solve all the maths problems. Today we're going to be working on lesson 4.2 discrete and continuous domains. We'll find this on page 156 of your books. So turn there and let's get started. The first thing that we're going to be talking about today are discrete domains. Remember from the last lesson, a domain is another word for the input or the x value in an ordered pair. And now we're going to add a little bit more detail to the domains. We're going to have two types of domains, either discrete or continuous. So we're going to start with discrete first. In a discrete domain, only certain values are included in an interval. Okay? Only certain numbers. So let's say my interval is 1 to 5. The domain are only the integers, only the real whole numbers. Okay? So what that would include is the integers from 1 to 5 would be 1, 2, 3, 4, and 5. Okay, those are the integers from 1 to 5. Now there are other numbers on this number line. Numbers such as 1.5, 2.5, 3.14, 4.682, and they're all in between the integers. Like 1.5 would be here, 2.5 would be here, 3.14 would be somewhere around here, right? So there's all kinds of numbers in between the integers, but we only include certain values. The integers, only 1 is included. Then you skip all of the numbers in between and you get to 2. You include 2 and then you skip all the numbers between 2 and 3 and you include 3. When this happens, you call this a discrete domain. Now the opposite of a discrete domain, or not the opposite, but the other kind of label that we can give a domain is a continuous domain. And a continuous domain is a set of input values that consists of all the numbers in an interval. Okay? So let's take the same interval of 1 to 5, so numbers between 1 through 5. Instead of the integers, we're going to do all numbers. So instead of just 1 and then skipping to 2, then to 3, then to 4, and to 5, we include all of the numbers. Okay? So this is going to include numbers like 1.5, 2.5, 3.14. Basically, if it falls anywhere on this number line, it's going to be included. When that happens, you have a continuous domain. Okay, so here is number 1. It says the function y equals 15.95x represents the cost y in dollars of x tickets for the museum. Okay? So what we know is that y is going to stand for the cost, the money that it takes to get into the museum, and that x represents the tickets that we buy. Okay? They want us to graph this function using a domain of 0, 1, 2, 3, and 4. Okay? So remember, the domain is x, so they want us to find out how much it's going to cost when we buy 0 tickets, 1 ticket, 2 tickets, 3, and 4. And we know that they're tickets because the problem says that x stands for tickets. Okay? Then the last part is that it wants us to tell whether the domain is discrete or continuous, and then explain. So let's tackle the easiest part first. Let's see what y equals when we buy 0 tickets. So we can assume that it's $15.95 per ticket. And when you buy 0 tickets, the cost is $0. Okay, because remember, y is 0. Okay, now let's see how much we have to spend in y if we buy 1 ticket. Well, 15.95 times 1, the total cost, remember in y, is going to be $15.95. And we keep on going. Each ticket would be, if we were to buy, or the total cost, excuse me, if we were to buy 2 tickets. Okay, so instead of X, we're going to plug in 2 tickets, and the total cost there, 15.95 times 2, should give us $31.90. So for 2 tickets, it's going to be $31.90. What about if you buy 3 tickets? The cost there should be $47.85. Again, all I've done is I've went through and I've multiplied 15.95 times 3, took the domain that they wanted me to find, and just plugged it in. The last one that they want us to find is, what is their cost when you have, remember they wanted us to do 4? Okay? And the cost then would be a total of $63.80. Okay, now looking back at the problem, it says that it wants us to graph the function. So what I need to do in order to graph it is I need ordered pairs, and that's what I went ahead and I put those answers that we got into ordered pairs. When we had 0 tickets, the y was 0 or $0. If we had an input of 1 or 1 ticket, the output was $15.95. When we bought 2, had 2 tickets, or had an X of 2, the cost was $31.9, or you can think of it as $31.90. I just didn't put the 0 in this case, but there is a 0 there. And since we know that y was money, we should go ahead and say $31.90. Okay? I have 3 and $47.85. And I have 4 tickets that are going to cost $63.80. So my next step is to actually put this. So I have a graph set up, and sorry if you can't read it. I did my best. It's really hard writing with fat fingers. So you'll see that along the bottom I have my X's. I have 0, 1, 2, 3, 4. I don't need to go any further because the problem doesn't ask me to go any further. It only asked us to do the domain of 0, 1, 2, 3, and 4. And so I did that, skipping a line in the middle just for some room. And then up the y, I looked at my range and I saw that the lowest that I had was 0, so I needed a 0. And the most I had was 63.8, so I just counted by tens, again skipping every other, so that hopefully to give myself a little bit of room here. And so what I need to do is I need to go through and I need to plot these points that I had, okay? So I'm going to do the best that I can with my fingers to get it on the intersection of the line, and I apologize if it's not perfect. What we have is our first point was 0, 0, so when we bought 0 tickets, it should be right there. It was $0, okay? Remember, this is y, this is the money over here, and then down here is the amount of tickets that you buy. Alright? When I had 1 ticket, it was $15.95, so I go over to 1, And I'm going to go up to about 15, which should be somewhere in there. 2 was $31.90, so 2 would be, go over to 2, up to about 31, somewhere in there. 3 should be $47.85, so close to here, not quite 50, a little bit more than 45. And then 4 should be $63.80, so 63 should be right here. Okay? Now I have to decide. The last part is the domain of the graph discrete or continuous? To answer this question, we have to ask ourselves, does it make sense that x not be a whole number? So what I mean by that is, could x be 1.5 or 2.5 or 3.5? In the real world, does that make sense? Can you walk up to a box office, go to the movie theater, the museum, wherever, and be like, hi, I would like to buy 1.5 tickets, please. They're going to look, you can do it, but they're going to look at you kind of awkward and think you're out of your mind. And so for this case, because x is tickets, we're not going to draw the line. This is discrete. You can only have integer number of tickets. 1 ticket, 2, 3, 4, 5, so on and so forth. Okay? You can't have 2.35 tickets. So we're not going to connect these points with a line. Alright, example number 2 reads like this. A cereal bar contains 130 calories, which I have up here. 1 bar, if you eat 1 bar, you're going to consume 130 calories. And the number of C calories, so C stands for calories, consumed is a function of the number B of the bars that you eat. We need to graph the function, and then we need to tell whether or not this is discrete or if this is continuous. So let's think this through. Let's start with just some domain numbers because the problem doesn't give us any. So let's say we eat 0 bars. How many calories did we consume? 0. Okay? Let's say B is equal to 1 and we eat 1 bar. How many calories did we consume? 130. Okay? Because 1 bar, remember up here, 1 bar is equal to 130 calories. So let's keep going and let's say that we eat 2 bars. Okay? How many calories did we consume? Well, if 1 bar is 130, then 2 needs to be 2 times 130, or 260. Okay? If we ate 3 bars, we would have consumed 390. You see how this works? And if we ate 4 bars, we would consume 520 calories. Alright, so here's the graph that I've set up for the problem that we were working on. On the bottom here we have the number of bars that we've eaten, 0, 1, 2, 3, 4. And up the side we have 1, 2, 3, 4, 5, 6, 700 calories that we could consume potentially. And I stopped at 700 because I looked at our ordered pairs and I saw that we went from 0 all the way up to 520. So I really could have stopped at 600. I didn't need 700, but I stopped there anyway. And so now we need to graph those ordered pairs that we had. Okay, so again I'm going to do the best that I can. We have 0 bars is going to be 0 calories, so that one's the easiest right there. 1 bar is 130 calories, so it's probably going to be somewhere in there. 2 bars is 260 calories, so maybe right in there. 3 bars is 390, so almost 400. And 4 bars is 520, so just a little bit past 500. Now we need to ask ourselves, is this domain, is it continuous or is it discrete? So let's ask ourselves, could we eat half of a bar? or 1.5 bars. Does that make sense? Is it possible? It is possible. Say the bar is really nasty, right? And you only want to consume half of it. That's possible. You don't have to eat the whole bar. In this case, since it's continuous, I'm going to do the best that I can. This should be straight. Yours will be straighter because you'll have graph paper and a ruler and a pencil and not a fat finger on a small board. Okay? We are going to connect it with the line. And that point should be on the line. But like I said, I'm drawing with a finger and it's hard to get there. So this is continuous because it is possible to eat half a bar, or even less, or a little bit more. So this one is continuous, so we do connect the points on the graph with a line. Alright, here's the on your own number 2. In this problem, you have a 20-gallon bathtub, and it drains at a rate of 2.5 gallons a minute. Okay? The number of G gallons remaining is a function of the number M in minutes. Okay? Your job is to graph the function and then tell whether or not it's discrete or continuous. Pause the video, get a graph paper or draw a graph and see what you come up with. Okay, the first thing you should come up with is you need to decide which one depends on the other. So, the M is going to be your X, or your input, because however many minutes have passed determines G, the output, how many gallons are left in the bathtub. So M is going to be your input, G is going to be your output. Alright, so let's see what we can come up with here. G stands for the gallons remaining. So the gallons remaining is going to be equal to the 20 gallons that we started with, because that's how much was in the bathtub when we began, or when we ended the bath or whatever. We had 20 gallons, and then we're going to minus 2.5 gallons for every minute that time goes by. Okay? So let's start with 0. Let's say that M is 0. After 0 minutes, how many gallons are there in the tub? Okay, so we have G equals 20 minus, remember the bath drains at 2.5 gallons a minute, but we haven't done any minutes yet. So a negative 2.5 times 0 is 0. So the gallons remaining after 0 minutes is 20. Okay? So at 0 minutes, you have 20 gallons remaining. That's our first ordered pair. Okay, let's try another one. The gallons remaining, because we need more points if we're going to graph, the gallons remaining is 20. That's what we started with. And we're subtracting 2.5 gallons for every minute. So let's find out how many gallons are remaining after 2 minutes. Okay? So 2 minutes. Negative 2.5 times 2 is 5. And so we're going to have G equals 20 minus 5. So the gallons remaining after M, when M is 2 minutes, is 15. So after 2 minutes, we have 15 gallons remaining. Right? 4 then. Let's try 4. The gallons remaining is going to be what we started with, and we're losing 2.5 every minute, and now we're up to 4 minutes now the tub has been draining. 4 times a negative 2.5 is 10. So after 4 minutes, we have 10 gallons left in our tank. Or, sorry, not in our tank, in our bathtub. Okay? Okay, we got to keep going here. Let's try the gallons remaining. After we're doing even numbers. So let's move on. Let's try 6 here. 6 times 2.5, 15. G, 20 minus 15. So after 6 minutes, we have 20 minus 15 gallons, or 5 gallons left. And let's do one more here. Again, that's the amount we started with, minus 2.5 gallons every minute, and now we're going to do 8. Okay? Negative 2.5 times 8 is 20, so we're going to have G equals 20 minus 20. So after 8 minutes, we have no more gallons left. Okay? Remember, I've written it in ordered pairs. M is for the minutes, and G is for the gallons that are remaining in the tub. So the last step that we need to do is we need to graph this. Alright, like I said, the last step is to graph this. And so let's graph the ordered pairs that we came up with. The first ordered pair that we had was 0:20, which means after 0 minutes, we still had 20 gallons left in the bathtub. After 2 minutes of draining, do you remember how many gallons we had left in the bathtub then? You should have had 15. So our ordered pair was 2:15. We'll put a point there. After 4 minutes, it was 10. So right there. After 6 minutes, it was 5. And after 8 minutes, the bathtub was completely drained. So I should have the ordered pairs 0:20. I should have 2:15. I should have 4 and 10. 6 and 5, which I do, and 8 and 0, which this graph is going down because we're draining the water, so the water level is going down, and now we need to decide, is this continuous or is this discrete? Can we only have 8 minutes, 6 minutes, 4 minutes, 2 minutes, and 0 minutes? Is that the only thing that makes sense? Is it possible to have anything in between? Well, of course it is. You could have 1 minute, you could have 3, you could have 5, you could have 7, you could have 2 minutes and 30 seconds. So this is a continuous graph, which means that we need to connect our graph with a line. So that way, if somebody wanted to come and look, well, how much water was left at 1 minute, well, they could go over here to 1 minute, go up, and they could look and say, oh, about 17 or so, okay? 17.5. And so this is continuous. Hopefully you got that right, and hopefully this makes sense to you. And of course, I will not leave you without the joke of the day. And our joke today is, what's a pepper that won't leave you alone? Jalapeno business. Bye everybody, we'll see you next time.